NASA's Pilgrim 1 spacecraft, which currently holds the record for the farthest distance traveled by any human-made object, has fascinated people across the globe for nearly 50 years. Since its launch, Voyager 1 has relayed vital data from the furthest parts of space, expanding humanity's understanding of the universe. However, the spacecraft's ongoing transmissions have recently faced strange anomalies that have left scientists puzzled. These mysterious signals have ignited intense discussion, making the scientific community question. 33 seconds. Whether these anomalies are simple malfunctions or signs of something much more extraordinary, possibly even extraterrestrial activity. Join us as we investigate these puzzling signals and explore what could lie hidden in the vastness of space. The human desire to discover the unknown has always been the driving force behind space exploration. This deep-rooted curiosity led to the development of ambitious missions like Pioneer 1 and Explorer 2, which were among the most daring space missions of their respective times. On September 5, 1977, Explorer 1 was launched, setting off on a path that would eventually take it toward the outer planets, significantly altering its orbit and the outcomes of its mission. These two spacecraft, each weighing approximately 7,720 kilograms and roughly the size of a small car, traveled in separate directions at varying speeds. On December 15, 1977, a significant milestone was reached when Explorer 2 was launched from NASA's Kennedy Space Center. 1 minute and 42 seconds. Explorer 1 surpassed its twin in distance traveled due to the different routes they followed. Since that time, Explorer 1 has proven to be an invaluable tool in broadening our understanding of the universe, offering insights that have transformed how we perceive space. Before we delve into some of its recent groundbreaking discoveries, let's first review some of its earlier major achievements. In 1978, while situated around 265 million kilometers from Earth, Explorer 1 successfully captured detailed imagery of Jupiter. By January 1979, after a remarkable 100-hour mission, the spacecraft released a time-lapse video of Jupiter's rotation. This series of 3,750 images provided unprecedented views of Jupiter's chaotic atmosphere and intricate features. The spacecraft also discovered a previously unknown ring encircling Jupiter and identified 2 new moons, significantly improving our understanding of the gas giant's complex system. To ensure its safe journey and avoid potential collisions with Titan. 2 minutes and 50 seconds. One of Saturn's moons, the spacecraft performed a series of correction maneuvers. Following this, the focus of the mission shifted beyond our solar system's planets, as the spacecraft was redirected toward interstellar space, traveling at an astounding rate of 325 million kilometers per year. In January 1990, Explorer 1 embarked on its mission to explore interstellar space, continuing its journey beyond the solar system. During this phase, the spacecraft achieved several remarkable milestones, including the discovery of 4. On February 14, 1990, at a distance of approximately 6 billion kilometers from the Sun, Explorer 1 took its famous family portrait, capturing stunning images of the inner planets. This collection of 60 images joined the spacecraft's portfolio, which also included 670 images taken during its flyby of Neptune. Explorer 2, meanwhile, also achieved impressive milestones during its mission, recording wind. 3 minutes and 23 seconds. Speeds that exceeded 13,100 meters per second, the fastest winds ever recorded in the solar system. This provided scientists with essential data on Neptune's distant atmosphere and its moon, Triton, which has surface temperatures that plunge to a frigid minus 391 degrees Fahrenheit, making it one of the coldest places in the solar system. Triton also displayed ice volcanoes ejecting nitrogen gas and frozen particles up to 5 kilometers high, offering an exciting new perspective on the moon's features. These extraordinary discoveries have 4 minutes and 32 seconds. Greatly enhanced our understanding of the diverse and dynamic environments in the outer reaches of the solar system. Both Explorer 1 and Explorer 2's missions were nothing short of groundbreaking. Their findings reshaped our understanding of the geologically active nature of the moons of Jupiter and Saturn, particularly Uranus, which had previously been thought to be dormant. 5 minutes and 4 seconds. And Neptune, an achievement that has yet to be repeated. NASA employed a variety of innovative strategies to extend the missions of these pioneering spacecraft, such as shutting down non-essential systems to conserve power. The mission is expected to continue until 2030, marking the end of an era for the engineers and researchers who have dedicated themselves to this extraordinary journey. The designs of Explorer 1 and Explorer 2 showcased cutting-edge engineering. These spacecraft were built to rotate slowly, 5 minutes and 35 seconds, minimizing image blurring as they traveled through space. Even before reaching the outer planets, the spacecraft began transmitting detailed images of Jupiter, revealing its swirling clouds and iconic Great Red Spot, a massive storm that has intrigued scientists for decades. However, the most exciting discovery came with the identification of active volcanoes on Jupiter's moon, Io. The spacecraft's instruments detected unusual signals from the moon, later confirmed by images showing towering volcanic plumes and a 6 minutes and 7 seconds surface marked by intense eruptions. One of Io's volcanoes erupted with a force 1,000 times more powerful than Mount St. Helens, covering an area nearly as large as France. As the spacecraft continued their journey, they were eventually powered down to conserve energy before beginning their voyage into interstellar space. Remarkably, the images they captured did not include Mercury or Mars due to technical limitations. NASA later launched other notable spacecraft, including Pioneer 10, Pioneer 11, and New 6 minutes and 38 seconds Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11 to become the farthest spacecraft from Earth. Despite this, Explorer 1 continued its solitary journey for an additional 14 years before finally entering interstellar space on August 25, 2012. The success of these Explorer missions was largely due to the innovative use of gravity assist maneuvers, which helped propel the spacecraft to their destinations while conserving fuel. The power of gravity assists. Rather than relying solely on their propulsion systems, the spacecraft employed gravity assists, using the gravitational pull of planets to increase their speed. This technique allowed them to cover vast distances without depleting their fuel supply. As Explorer 1 approached Jupiter, the planet's immense gravity accelerated the spacecraft. Precision was essential to avoid catastrophic deviations in trajectory or speed, and these maneuvers allowed the spacecraft to navigate its journey through the solar system and beyond. Similarly, Explorer 2 utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune, demonstrating the efficacy of this technique. Reflecting on the immense accomplishments of these missions, we eagerly await further insights into the recent anomalies detected by Explorer 1. The Voyager spacecraft continue their missions beyond the known limits of our solar system, exploring the mysteries of Jupiter, Saturn, Uranus, and Neptune. Explorer 1's time-lapse images vividly captured 10 eruptions on Jupiter, in addition to revealing new moons and a previously unknown ring surrounding the planet. These discoveries have greatly advanced our understanding of Jupiter's system. Explorer 1 also identified 4 new moons of Saturn, including Mimas, Enceladus, Tethys, and Rhea, and captured beautiful photographs of the planet and its rings. The quest for interstellar knowledge. 8 minutes and 49 seconds. Voyager 2 set its sights on interstellar space, where it continues to collect invaluable data. This ongoing research is expanding our understanding of the universe beyond our solar system. As we await more details on Explorer 1's unusual signals and their implications for our understanding of the cosmos, the remarkable journeys of these spacecraft continue to inspire awe and wonder among scientists and space enthusiasts alike. Their achievements persist in advancing our collective knowledge and pushing the boundaries of anomalies beyond the solar system. The signals from Explorer 1 had grown increasingly strange. At first, scientists suspected simple hardware malfunctions. After all, the spacecraft had been traveling through space for nearly 5 decades. However, further analysis revealed something unusual. The anomalies were not random. Patterns emerged in the transmissions, fluctuations in frequency, repeating sequences, and even disruptions that coincided with certain cosmic events. Some speculated that Explorer 1 had encountered an unknown interstellar phenomenon, while others entertained a more profound possibility: intelligent signals from beyond. As the data poured in, researchers noticed a peculiar delay in transmission. Explorer 1's radio waves, which should have followed predictable interference patterns as they traveled through interstellar space, were being distorted in a way never seen before. The leading theory suggested that the spacecraft had passed through a region of space unlike anything previously encountered, a zone where the very fabric of spacetime itself might behave differently. A breakthrough in the unknown. On March 12, 2025, NASA's Deep Space Network detected the most startling signal yet, an encoded sequence that did not match any known natural phenomenon. It was structured, deliberate. A team of cryptographers and astrophysicists quickly assembled to decipher the signal, comparing it against existing mathematical and linguistic models. To their astonishment, part of the transmission resembled prime numbers, a universally recognized pattern often suggested as a method for extraterrestrial communication. But the true shock came when an unexpected anomaly was uncovered within the data, a sequence resembling Earth's own radio signals, but distorted, as if they had been reflected back from an unknown source. Could this be an echo of our own transmissions bouncing off an unknown object in deep space? Or was something, or someone, deliberately sending them back? The race to respond. With tensions high, NASA debated its next move. If this was a message, should we respond? What if it was a warning? A new mission proposal was drafted, Project Echo, an effort to send a powerful, encrypted reply back to the source of the anomaly. The goal? To establish whether the signal was merely a cosmic coincidence, or the first proof that humanity was not alone.